Okay, so yesterday we learned to draw angles in standard position and find reference angles. The goal was to be able to draw the pictures that we need to evaluate trig functions for angles in standard position. So that's what we're going to tackle today. I have 3 quick examples that'll get you ready for the work that's posted on Schoology. It's posted in the form of a quiz. You're going to go through and click on the multiple choice answers after you draw your pictures and work things out on your own paper. And we'll just take a look at what we have on paper when we get back from school, back to school from our snow day later. So we're going to start with just one of 3 examples. We want to evaluate without a calculator the cosine of, say, 120 degrees. If we don't get to use a calculator, we have to have a picture. So the first thing we want to do is crunch out a picture of 120 degrees in standard position. And so if we start at 0 degrees and rotate 90 and a little bit more, that takes us into the second quadrant. So about 120 degrees is there. The reference angle between that terminal side and the x-axis is 60 degrees, since 120 plus 60 more will give us 180, halfway around the circle. Then we need to draw something called a reference triangle. So we take any point on the terminal side, so we'll just pick a point, that's one, and we're going to drop a perpendicular, in other words, make a right angle, with the x-axis. So we'll drop a vertical side of the triangle. It's always a vertical side, always perpendicular to the x-axis. The point being to make a triangle with the reference angle 60 degrees in it. So we want to make sure we always connect to the x-axis, never over to the y-axis. This then is a 30, 60, 90 triangle. So we have a special case. That's one of those special ones that we're supposed to have memorized by now. So opposite the 30, we have a side length of 1. Opposite the 60, we have a side length of square root of 3. And then the hypotenuse is twice as long as the short leg. Now, if we were in the first quadrant, all those numbers would be positive. But when we get out of the first quadrant, we get negative values. So we want to actually look at the displacement of each side length from the origin. So if we start at the origin and go to the left one, we're going to get this bottom side of the triangle. So I want to think of that as a negative 1 because it's to the left of the origin. The radical 3 goes up where the positive y's are, so we're going to leave that positive radical 3. The hypotenuse is never, ever going to be negative because technically we do negative 1 squared plus square root of 3 squared, and then take the square root of the sum of those to get the 2, and that's always going to turn out to be positive. Once you get the triangle drawn, you're ready to evaluate your trig function. So to find cosine 120, well, 120 is on the triangle, so that's not going to help us any. But this reference angle here, this 60-degree reference angle, if we find the cosine in this triangle of that reference angle, that will actually give us the cosine of 120. So if we do the adjacent leg, because cosine's adjacent over hypotenuse, the adjacent leg to 60 is negative 1. So the top number is going to be a negative 1. And then the hypotenuse is our bottom number. Hypotenuse is 2. So the cosine of 120 degrees is negative 1/2. I could check it on the calculator. If I do cosine of 120 degrees in the calculator, it's going to spit out negative 1/2 or a negative 0.5, which is equivalent. These you'll need to be able to do without a calculator on test day, so you want to practice drawing the pictures and crunching that out by hand. If I wanted to find other trig values, the picture's already there, that's going to go real quickly. If I want the sine of 60, that's opposite over hypotenuse, that's radical 3 over 2. It's done. If I want the tangent, opposite over adjacent, radical 3 over negative 1. So you can find all of your trig functions once you get your picture drawn. Okay, let's take a look at one with a radian angle measure. So we'll scroll down here and we'll call this example 2, make it a little bit bigger. Let's find this time the sine of negative 3 pi over 4. It's radians because there's no degree symbol. And the first thing we want to do is draw a picture. So let's crunch out a coordinate plane. A negative angle is going to have a clockwise rotation. And to get 3/4, I first want to divide pi, half a revolution, into 4 equal parts. So imagine 1, 2, 3, 4 pieces. And I want to rotate 3 of those 4 pieces. So 1/4, 2/4, 3/4 is going to take me right into the middle of quadrant 3. And I have a gap in the table under here that I keep getting hung up on. So -3 pi fourths is that angle. The reference angle that's left between that terminal side and the x-axis is the other fourth of a pi, so that's pi over 4, which is the same thing as 45 degrees. So our reference angle is pi fourths, or 45 degrees. We're going to pick a point on the terminal side to connect with a perpendicular back up to the x-axis. It's always a vertical, makes a right angle. And we have then a reference triangle that's a 45, 45, 90. And we should know by now that in a 45, 45, 90 we have ratios of sides 1, 1, square root of 2. From the origin, we have to go to the left to get the horizontal side, so we're going to think of that as a -1. And then we have to go down to get the vertical side, so we're going to think of that as a -1. So in the third quadrant, both of those legs are going to be negative. In the fourth quadrant, we'd have a positive, comma, a negative as we go down. Hypotenuse is always positive. Don't try to make that a negative ever. Once your sides are labeled, you're ready to evaluate your function. So we're looking for the sine of -3 pi over 4. To find that, we're going to have to use the reference angle over here by the origin, that pi over 4 by the origin. We don't want to use this one down here. We're going to use the reference angle every time. Sine is opposite, that's -1. Over the hypotenuse, that's radical 2. And if we were just doing pencil paper work, that would be sufficient. We could leave that -1 over radical 2. On your assignment today, it's a multiple choice quiz straight from our test bank. So before you can match that up with an answer, you're going to have to rationalize, because the multiple choice answers will always be in rationalized form. So we're going to keep a -1, move a radical 2 up. So -1 radical 2, normally we just drop that 1 and make it negative radical 2. Over, drop the radical in the bottom, and we get a 2. And negative radical 2 over 2 is the final answer. All right, one more example and we'll wrap it up. Sometimes we get an example or a case where it's not a special right triangle. We don't have a 30, 60, 90 or a 45, 45, 90. In that case, they'll give us information in a different way. So example 3, example the last one. Let's say that the point 3, -7 is on the terminal side of some angle theta in standard position. And we want to find the cosecant of theta. So again, we need a picture. And this time they're giving us 2 sides of the triangle. So instead of a special case, we're just going to use the side lengths that they give us. So we'll start with a picture. Go to this side this time. So I need to find the point 3, -7. Okay, so 3, -7. Notice I'm not making a bunch of tick marks. I don't have time for that. I'm going to skip straight to the chase. 3, -7 is down in the fourth quadrant somewhere. And it says the terminal side contains that point. So that means the terminal side of our angle goes through that point. It extends on past it, so you can make that as long as you want it. So we have an angle in standard position that has ended there. So it may have been a positive angle that's circled around. It may be a negative angle that's come down to it. It doesn't really matter. So theta is some angle that ends there, which means we have a reference angle here called theta prime. I don't know its angle measure, but I don't need to. It doesn't matter. All I need are side lengths for the triangle. So I'm going to have to complete my triangle. So pick that point 3, -7 and connect it to the x-axis with a perpendicular. 3, -7 gives me 2 of the side lengths of this triangle. So from 0, 0, if I go over 3, that's the top side of the triangle. Then down 7, that's the vertical side of the triangle. All I need now is the hypotenuse. This is not a Pythagorean triple, which means I'm going to have to do a little bit of a Pythagorean theorem here. So 3 squared plus -7 squared equals some hypotenuse c squared. I'm going to go ahead and just take the square root of both sides and just get it all done in one step. All right, let's see. 9 plus 49 is 58. So this is the square root of 58. 58 doesn't have a perfect square factor in it, so we can't do anything else with it. That's the simplest form. So we'll just stick a square root of 58 on this hypotenuse and be ready to evaluate our trig function. So I'm looking for the cosecant of theta. Cosecant is the reciprocal of sine, so I need hypotenuse over opposite. The hypotenuse of this triangle is radical 58. We just found that. The opposite side from theta, well, theta is not in the triangle, but theta prime is. We're going to use that reference angle every single time. So from theta prime, opposite is -7. So -7. Now we could leave it that way. We don't need to rationalize since the radical's in the top. But it's considered bad form to leave negatives in denominators. So when I go looking for a multiple choice answer, it's either going to move the negative to the front and do negative radical 58 over 7, or move the negative to the top. And that's still an equivalent value. So you're probably going to be looking for this version in your multiple choice answers. And that's all you need to know. So you have 14 questions in the form of a quiz. Work them out on paper, and then just click on the correct answer to get credit for that Schoology component that you need today. And if you have questions, you can email me or you can message me through Schoology, and I will do my best to get back to you quickly. Enjoy your snow day.